Hi students, I am Priyanka Jain and I am a verified educator at the Unacademy Plus platform. You can watch several of my Plus classes. Okay, I have soon started a Catalyst batch course for the whole inorganic chemistry. You will see whole the inorganic chemistry in this course, and this is for the upcoming June 2022 exam of the CSIR net as well as for the GATE exam. Okay, so if you want to see different of the my lectures, different courses, you can see on the Unacademy. Take the subscription of the Unacademy. And if you want to see the free classes, there are also several free classes. Every month I take several free classes. You can watch these free classes without taking subscription. So for this, you will have to uncode my code. My code is Priyanka Jain 10. By clicking on this code, you will get the link for my classes. Thank you. Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching the acid and bases and the non-aqueous solvents, unit 3rd of the inorganic chemistry. So in our last lectures we have studied about the acid and bases. Now we will study about the non-aqueous solvents. Okay, so first of all, the main solvent is the liquid NH3. Okay, so we have to study now about the liquid ammonia. Liquid ammonia is a protonic solvent. Like water, it is a protonic solvent. So first of all, see its autoionization, how its autoionization takes place. Whenever we are studying about the non-aqueous solvents, we should know about their autoionization, how their autoionization takes place. It means the self-ionization. As we have seen in the case of water, if you have seen in the case of water, we take 2H2O and its autoionization gives H3O plus and OH minus ions, right? Similarly, in the case of liquid NH3 will self-ionize and it will give NH4 plus and NH2 minus ions. Okay, so this is like the water. In water, any species that is giving H3O plus is known as the acid, we know, and any species that is giving OH minus ion will act as the base. Similar happens in the case of liquid NH3. In liquid NH3, any species that is giving NH4 plus ions will act as acid. It means acids are the substances that are giving NH4 plus ions in liquid NH3. Okay. Similarly, any species that is giving NH2 minus ions will act as the base. So what are bases? According to solvent concept, the bases are the substances that will give the NH2 minus ion in liquid NH3. Okay. So by this we can detect the acids and bases in the liquid NH3. So now we have to study the reactions that are happening in the liquid NH3. Okay. So the first reaction that happens in the liquid NH3 is the precipitation reactions. As we have seen in the case of water, several precipitation reactions can be done in the water. Similarly, there are several reactions that happens only in the liquid NH3. Actually, the precipitation of any substance depends upon the solubility of the substrate in that particular solvent. Okay, some substances are soluble in water while some other are soluble in liquid NH3. Okay, so this is the basic criteria that happens. Actually, see here, we know that whenever HAgNO3 is treated with KCl, we get AgCl precipitate. Okay, AgCl is precipitated and we get KNO3. This reaction happens in water. So we are writing here water. Okay, this type of reaction happens in water because AgCl is less soluble in water. It gives the precipitate. But opposite reaction, the reverse reaction of this can happen in the liquid NH3. Means AgCl plus KNO3 are when treated in liquid NH3. Always remember, when you are doing the reaction in liquid NH3, here you should write liquid NH3 above the arrow. Okay, so this reaction is happening in liquid NH3. So AgCl and KNO3 reacts together and forms AgNO3 plus KCl. So here we are getting the precipitate of KCl. So that reaction that cannot happen in the water can be done in the liquid NH3. There are several other precipitation reactions that cannot happen in water, can be easily done in liquid NH3. See here some more reactions. SrNO3 whole twice is reacting with 2NH4Br. Okay, and here write down liquid NH3, and by this we are getting SrBr2. This will get precipitate. plus we are getting 2NH4NO3. One more reaction of this type, ZnNO3 whole twice plus 2NH4I. Okay, these are reacting in liquid NH3 and it is forming ZnI2 and this is forming ZnI2. This is precipitated and we are getting 2NH4NO3. Okay, similarly NH4 whole twice S can be reacted with silver nitrate. These all reactions are happening in liquid NH3 and this cannot be done in water. Okay, so this is the specialty of these solvents, that the reactions that we cannot done in water can be easily obtained in the liquid NH3 or other solvents. See here we are getting the precipitate of silver sulfide. Similarly, NH4 whole twice S is when treated with CuNO3 whole twice in liquid NH3. We are getting CuS plus 2NH4NO3. Okay, so these are the precipitation reactions that are happening in liquid NH3. Now see one more type of reaction. Alright, now see the acid-base reactions. The second type of reaction are the acid and base reactions. It means the reaction of the acids or the bases. As we all know that in liquid NH3, any substance that is giving NH4 plus ions is acting as the acid, while any substance that is giving NH2 minus ions will act as the base. So we can say NH4Cl. If we are taking NH4Cl, then it is giving NH4 plus ions, okay, plus Cl minus. So it is acting as the acid. It is called ammono acid. Okay, this is called ammono acid. Similarly, if we are taking here KNH2, it is giving K plus plus NH2 minus. So this is giving NH2 minus ion. So it is acting as the ammono base. This is a base. As it is acting as a base in the liquid NH3, we are calling it the ammono base. Okay. Now see one of the important reactions of the amino acids and ammono bases. We are seeing here the reactions of amino acids. So first of all, one important reaction is the neutralization reaction. What is meaning of neutralization reaction? You all know what is the meaning of the neutralization reactions. Whenever the acid and the base reacts together. Okay. This is we have seen in the case of water. Whenever acid and base reacts, they form salt. Plus they form solvent. Okay. If a simple reaction you see in the case of water, if HCl is reacting with NaOH, okay, then it is forming NaCl plus H2O. Okay. So now you can see here, this is acting as the acid while this is acting as the base. This is acid and this is base. And this is forming, this is salt and this one is the solvent. This reaction is happening in H2O. Okay. So this is called the neutralization reaction. Similar type of reactions we can do in the liquid NH3. See here, NH4Cl. Okay. It is giving NH4 plus plus Cl minus. Similarly, KNH2 is reacting and it is forming K plus plus NH2 minus. Okay. Now these two can combine. K plus will combine with Cl minus and it is forming KCl, and NH4 plus is reacting with NH2 minus and it is forming 2NH3. What is meaning to say? Acid and base are reacting together and forming the salt and the solvent. Okay, so basic concept is that NH4Cl and KNH2 are reacting together and it is forming KCl and the solvent. So this reaction is known as the neutralization reaction. Okay, now see one more reaction of the amino acids. Second reaction of the amino acid is the replacement of proton by reactive metals. As you have seen in the case of water, what happens? We react with sodium or with other metals. We are getting the hydrogen. The hydrogen gas is evolved. Similar can happen in the case of liquid NH3. Ammonium salts reacts with the metal in liquid NH3 to give hydrogen. For example, Na is reacting with NH4 plus in liquid NH3. It is reacting in liquid NH3 and it is forming Na plus NH3 plus half H2. Okay, similar type of reaction. If we are reacting CO with 2NH4NO3, cobalt metal is treated with ammonium nitrate in liquid NH3. Then it is forming CONO3 whole twice plus 2NH3 plus H2. Okay, so now you can see here the metals are directly reacting with the amino acids. This is the amino acid. It is reacting with it and it is forming the salt and the hydrogen gas is evolved. So this is the basic reactions of the acid and here this is the basic reaction of the amino acids. Okay, third type of reaction is called the protolysis. Protolysis means certain compounds like urea, like acetamide, like sulfamide etc. that are unable to donate the protons in water. If you know urea or acetamide, any of these substances, if you take in the water, they does not give you protons. Okay, these are not donating the protons to water, but they readily donate the protons to the liquid NH3. It means these are acting as the acid in liquid NH3. It cannot happen in the water. These cannot act as the acid in the water, but they can act as acid in the liquid NH3. They can donate protons. For example, see here NH2CO NH2. If it is treated with NH3, it is forming NH minus CO NH2 plus NH4 plus. Okay. Similarly, CH3 CO NH2. This is acetamide. Okay, this is reacting with NH3 and it is forming CH3 CO NH minus plus NH4 plus. Okay, so these are the some of the reactions of the amino acids. Now we see some of the reactions of the ammonobases. Okay, so see here now the reactions of ammonobases. Ammonobases means any substance that is giving NH2 minus ion in liquid NH3, it acting as the base. That is called the ammono base. Okay, like any substance that is possessing NH2 group or that is possessing imide. This is imide and this is nitrite. Any of these substances will act as the base. These all will act as the base in liquid NH3. Okay, this will act as base in liquid NH3. For example, if you are taking NH2 and treating it with the NH3, then it is forming NH3 plus NH2 minus. Now you can see here we are getting NH2 minus. So it is acting as the base. Similarly, if you are taking imide and treating it with the ammonia, then it is forming double bond NH2 plus. It is accepting the proton and it is forming NH2 minus. So it is acting as the base. Similarly, if you are taking the nitrite and treating it with NH3, then it is forming triple bond NH plus NH2 minus. So now you can see all of these compounds are giving the NH2 minus ion. So these are acting as the base. These are acting as the ammonobases. Okay. Strong bases. Strong bases means O minus minus H minus. These all will act as the weak base. These are the strong bases in the water, but these are acting as the weak base in liquid NH3. For example, see here H minus. If it is treated with NH3, then it is forming NH2 minus plus H2. Similarly, if you are treating oxide minus minus with NH3, it is forming OH minus plus NH2 minus. Okay, so these all are acting as the base but weak base in the liquid NH3. Okay, now the next thing is the amphoterism. Several compounds act as the amphoteric behavior. They show amphoteric behavior. Amphoteric means they can act both as the acid as well as the base in the liquid NH3. For example, zinc amide. Zinc amide shows the amphoteric behavior in the liquid NH3. For example, if you are treating zinc NH2 whole twice zinc amide with 2NH4Cl, it means it is reacting with the amino acid. So it is acting here as the base, right? Any substance that is acting with the acid will act as the base. So now it is forming ZnCl2 plus 4NH3. Okay. Similarly, ZnNH2 whole twice is reacting with 2NaNH2. Okay. In liquid NH3. It is acting in liquid NH3. So it is forming now Na2Zn NH whole twice plus 2NH3. Okay, now it is reacting with the base, so it is acting as the acid. In this reaction, it is acting as the base, while in this reaction, it is acting as the acid. So it is showing the amphoteric behavior. Okay, now the next type of reaction. Now the next type of the reaction is the ammonolysis. Ammonolysis is similar to hydrolysis. As you have studied about the hydrolysis, hydrolysis means, what is means of hydrolysis? If you have seen hydrolysis, salt is reacting with the water. Okay, you know in water what happens? Salt reacts with water. Okay, this is called the hydrolysis and it forms acid and bases. Okay, so similar type of reaction can happen in the liquid NH3. Salt can react with ammonia. Okay, salt is reacting with ammonia and it is forming ammono acid and ammonobase. So this reaction will be now called the ammonolysis. Okay, this is the ammonolysis reaction. As it is hydrolysis, similar to this reaction is ammonolysis. Okay, means to say the salt and the solvent are reacting to form acid and the bases. Okay, for example, see here one reaction. If we are treating NaCl4, it is forming Sn plus 4 plus 4Cl minus. Okay. Now we dates the ammonia 4NH3 plus 4NH3. Okay. Its autoionization. See here. Its autoionization happens and it forms 4NH4 plus 4NH2 minus. Okay. Now this Sn plus 4 is reacting with 4NH2 minus and it is forming SnNH2 whole 4. Okay, it is forming SnNH2 whole 4. Similarly, NH4 plus is reacting with Cl minus ion and it is forming NH4Cl. So what we are getting, this was the salt and this was the solvent. Now these are reacting and it is forming this. This one is called the base and this one is called the acid. It means by the reaction of the salt and the solvent, what we are getting? We are getting acid and base. So this reaction is a very important example of the ammonolysis reaction. Okay, now the next type of the reaction is ammonation. Ammonation reaction is similar to hydration. As hydration happens in the water, similarly in ammonia, ammonation can occur. SO3 is reacting with 2NH3 and it is forming SO3 2NH3, right? Similarly, SiF4 is reacting with 2NH3 and it is forming SiF4 2NH3. Okay. Similarly, BF3 is reacting with NH3 and it is forming BF3 NH3. Okay. So this is the way in which the ammonation reaction is happening. Another important type of the reaction is called the complex formation. Several complexes can also be formed in the liquid NH3. See here, like ZnNO3 whole twice is reacting with 2KNH2 in liquid NH3. This reaction is happening in liquid NH3 and it is forming Zn whole twice plus 2 KNO3. Okay. Similarly, AgNH2 can react with KNH2 and it can react in liquid NH3 and it is forming KAgNH2 whole twice. Okay, so in this way this reaction can happen. So you can see here in both the reaction complexes are formed, so it is a good solvent for the formation of the complex also. Okay, another important reaction is the reduction reaction. The reduction reaction can also happen in the liquid NH3. Liquid NH3 is actually a good medium for the reduction reaction to occurs. For example, CuY can react with Na in liquid NH3 and it can form Cu plus NaI. Okay, but oxidation reactions generally not happens in the liquid NH3. Actually, liquid NH3 is not a good medium for the oxidation reaction to occurs. Okay, a very rare reactions can happen only. It can occur the reduction reactions. The reduction reactions can very smoothly be carry out in the liquid NH3. So these are the some of the very important reactions of the liquid NH3 that you should do. Okay, all the reactions that I have done here, you should practice these of the reactions. Meets you in the next video with some more solvents. Okay, with some more concepts, with some more theories. If you are liking these videos, please comment me. Thank you.